Welcome to chemistry classes. In this video, we are going to discuss about polymers. Okay. So here, this is the third part of organic chemistry. You can watch first and second part. Then you can watch this video. So here we have to discuss here polymers. Polymers are heavyweight molecule. Polymers are heavyweight molecule, and these polymers are formed by repeated addition of small unit. Repeated addition of small unit. This small unit join to form a big heavyweight molecule. These heavyweight molecules are called polymers. Clear? So look here. This one represent polymerization. See here, many small unit join to form a long chain molecule. Here this type of n number, n represent 100 or 1000 or million small unit join to form a long unlimited molecule. See here, this chain continue over here, also over here. Okay, then a long chain molecule formed. This long chain molecule formed called polymer, or you can say macromolecule or polymer. So here one of the single unit, this is the single unit, this single unit called monomer. So here we have to discuss here polymerization. Polymerization means repeated addition of small unit, many small unit, repeated addition, it will change to a long chain molecule. This process is called polymerization. The process by which polymers are formed, this process is called polymerization, and product obtained, the obtained product, that is polymer or macromolecule. Clear? Look here, one example for polymerization process. We know this is ethene. Okay, so here, look here, 1, 2, 3, 4, 5, 6. 6 ethene molecules after repeated addition, it form a long chain molecule, a long molecule. Okay, here 1, 2, 3, here 3 CH2 3 unit I did here. Remaining 3 molecules also continue over here. Okay, so here 6 CH2 6 ethene molecule after repeated addition, it form a long chain molecule. Okay, and this long chain molecule called polymer. Okay, you can say here, look here, this one unit, it is ethene. We know this is ethene, and this is single unit, this is monomer. This single unit after repeated addition, a big heavyweight molecule formed. This big heavyweight molecule called polymer. Okay, so here it is ethene after polymerization, polyethene. Ethene after polymerization, you can write like this, polyethene. Okay, this polyethene, you can say polythene or polyethene. Okay, so this is one example for polymer. So we did here only 6 unit, but actual polymer with it contain 1000 or million number of small unit. Okay, and we cannot draw all this 100 or 1000 unit, we cannot draw. So simply or shortly we can do it. Look here, this is the long chain molecule of polythene. So here we know CH2, it repeating many times. So this is the repeating unit. So I choose here one repeating unit, CH2, then put one bracket over here, then put N. So it represents polythene. It represent polythene. Okay, so actual polymer, it contain 100 or 1000 or million number of small unit. We cannot draw in paper, we cannot draw. Okay, so to represent such type of polymer, we will choose the repeating unit. Here CH2, CH2. Okay, CH2 double bond CH2 after repeated addition. Here addition reaction takes place. In polymerization reaction, here repeated addition. We know after addition double bond will change to single bond. So here in monomer there is double bond, but in polymer there is only single bond. We know addition reaction, we discussed already in organic chemistry part 2 video. We discussed addition reaction, you can check it. So in addition reaction double bond will change to single bond. So this is polymer and this is the repeating unit. So we have to select the repeating unit, then put bracket and put here n. This n represent number of monomer. Number of monomer may be 100 or 1000, depends on the chemical reaction. Okay, so this is the representation of polymer. Clear? So here we discussed polymerization reaction. Here we discussed polymerization reaction. Polymerization reaction mean, or polymers are heavyweight molecule. These heavyweight molecules are formed by repeated addition of small unit. These small units are called monomers. Example for such type of chemical reaction, ethene after polymerization it will be polythene. Ethene, polythene. Imagine propene. If your repeating unit propene after polymerization polypropene, we had to add polypropene or polythene. This poly, it represent many. Poly mean many. Many ethene molecule join to form a polymer, that is polyethene or polythene. Clear? Okay, next one we have to understand here classification of polymers. Polymers are classified natural polymers and synthetic polymers. Natural polymers and synthetic polymers. Naturally getting polymers are called natural polymers. For example, plants produce some polymers such as cellulose, carbohydrate. Okay, this type of polymers are natural polymers. Man-made polymers which made in factory, okay, chemical factory. Such type of polymers are called synthetic polymers. Example for synthetic polymer. Example for synthetic polymer. We discussed already polythene, polypropene, nylon, Dacron. This type of polymers are example for synthetic polymer. Okay, so here we discuss classification of polymers. We have two different type of polymer, synthetic polymers and natural polymer. Synthetic polymers and natural polymer. Look here, polythene, polypropene, nylon, terylene. Also look here, chewing gum. Chewing gum also one type of polymer. It is synthetic polymer. Okay, also here plastic, hair gel, showering gel, these gels which contain water soluble polymers. Okay, so here we discuss synthetic polymer, polythene, polypropene, nylon, terylene, chewing gum. Similarly here plastic, hair gel, shower gels. Okay, shower gels which contain water soluble polymers. Clear? Also we have another classification, natural polymers. I told you natural polymers mean naturally getting polymers are natural polymer. The major source of natural polymers are plants. Okay, plants produce, plants do photosynthesis. Plants make their own food with help of carbon dioxide, water in presence of sunlight. They do photosynthesis. Okay, the product formed by photosynthesis, it is glucose. Okay, many glucose unit join to form carbohydrate. Many unit of glucose join to form carbohydrate, cellulose, etc. Cellulose, carbohydrate, these are the polymers. These are some example for polymers made by plants. The basic unit of cellulose, carbohydrate are glucose. The basic unit, it is glucose. Clear? Also see here some other example for natural polymer. Example for natural polymer, I told you starch. Starch is a polymer made by plants. Okay, and the basic building unit of starch, it is glucose. The monomer of starch, it is glucose. Similarly, cellulose. Cellulose also a macromolecule, or cellulose also polymer made by plant. Okay, the basic unit of cellulose also glucose. Starch, cellulose, the basic unit, it is glucose, and major source plants. Clear? Look here, our body, skin, hair, bones, muscles also contain different type of polymers such as protein. Okay, our body contain a polymer, it is protein. Protein is made up of amino acid. Different type of amino acid. Many amino acid join to form protein. Okay, so the monomer of protein is amino acid. The smallest unit of protein, amino acid. That's mean monomer of protein, it is amino acid. Okay, and what is the monomer of starch? Monomer of starch, glucose. What is the monomer of cellulose? Monomer of cellulose is glucose. What is the monomer of protein? Monomer of protein is amino acid. Clear? Look here, hair, nails, wool, animal horns, these are polymers which contain keratin. Okay, the chemical keratin or biological material keratin present in hair, nail, wool, animal horns. Okay, so this keratin also one type of polymer. It is example for natural polymer. So here cellulose, carbohydrate, protein, keratin, these are example for natural polymers. Natural polymers are found in animals and plants. Clear? Okay, next one we have to discuss here different type of polymerization. Different type of polymerization reaction. We already discussed the process by which polymers are formed. Such type of process called polymerization. There are different type of polymerization. Addition polymerization and condensation polymerization. These are two different type of polymerization. Addition and condensation. Addition and condensation. Okay. So addition polymerization means molecules which contain carbon-carbon double bond. Monomers which contain carbon-carbon double bond, okay, it will undergo addition reaction, addition polymerization. Okay, example for addition polymerization, this one already we discussed before. Ethene after polymerization, polythene. Ethene after polymerization, it will change to polythene. Okay, see here, this is monomer which contain carbon-carbon double bond. After polymerization, this is polymer. Okay, here carbon-carbon single bond only. So during addition polymerization, carbon-carbon double bond will change to carbon-carbon single bond. During addition chemical reaction, addition polymerization, unsaturated Unsaturated compound changes to saturated compound. Unsaturated compound which contain carbon double bond, it will turns to saturated compound. Saturated compound mean compound which contain carbon single bond. Clear? So this is best example for addition polymerization. Ethene changes to polythene. This chemical reaction takes place in presence of some catalyst. Okay, mixture of titanium and aluminum compound, a mixture which contain titanium and aluminum compound. This mixture act as catalyst during polymerization of ethene, during formation of polythene. Okay, so here we discuss addition polymerization. Addition polymerization mean actually it is addition reaction. Alkene undergo addition reaction. So addition polymerization mean actually it is addition reaction. Monomers which contain carbon double bond, after addition reaction double bond changes to a compound which contain carbon single bond. Clear? Okay, next one we have to discuss here more example for addition polymers. More example for addition polymers. See here. You have here ethene. Ethene after polymerization polythene we discussed already. This is another one. Look here, 3 carbon atom. This molecule which contain 3 carbon atom, it is not ethene. Okay, here 1, 2, 3. 3 carbon and double bond. So it is propene. Propene after polymerization it will be polypropene. Propene after polymerization polypropene. Similarly here it is carbon, 2 carbon, here not hydrogen, here chlorine. Chloroethene. This is chloroethene after polymerization polychloroethene. Chloroethene after polymerization polychloroethene. This is, here you can see 4 carbon. 1, 2, 3, 4. 4 carbon and there is double bond. 4 carbon. So bute. Okay, butene. Butene after polymerization polybutene. Butene, polybutene. Okay. And here this is another one. Here not hydrogen. Here you can see this 2 carbon which contain 4 fluorine atom. So it is tetrafluoroethene. Tetrafluoroethene after polymerization polytetrafluoroethene. You just add poly. Poly mean many. Okay, tetrafluoroethene after polymerization polytetrafluoroethene. You understand? So here you have one more example here. This is styrene. Here C6H5. C6H5, C double bond C, then 2 hydrogen. Okay, so this is phenylethene. Here this C6H5, this is phenyl group. Okay, so phenylethene after polymerization it will be polyphenylethene. This phenylethene also called styrene after polymerization polystyrene. Similarly, look here, this is chloroethene. Chloroethene also called vinyl chloride. Chloroethene, polychloroethene. Okay, chloroethene also called vinyl chloride. Vinyl chloride, so after polymerization it will be polyvinyl chloride, PVC, polyvinyl chloride. Clear? So these are monomers and this is polymers. Okay, so to convert this monomer to polymer, it is very simple. Okay, you have to remove, imagine carbon double bond. Here it is CH3, hydrogen, these are hydrogen. Okay, this is propene, same molecule. So the question asking you, draw the structure of polymer. Draw the structure of polymer of this monomer. So you know this is propene, 3 carbon and double bond. So it is propene. Propene after polymerization it will be polypropene. So to draw structure of polymer of this molecule, you just do one thing, remove double bond. We know during addition polymerization double bond will change to single bond. So during polymerization unsaturated will change to saturated. Okay, so you just remove double bond. Okay, and this is one unit. Polymer mean many unit. This type of many unit will join. Okay, so here and here many unit will join. Okay, this bracket and n represent this is one unit. This type of unit will join this side and this side, unlimited, depends on this n. If there is 1000 molecule, so here also 1000 molecule will be here. Okay, here 1 million, so here also 1 million. Okay, so depends on this n. So you just write here n. That's it. Clear? Look here, another example I will give you here. See here, styrene. Styrene mean carbon-carbon double bond. Here C6H5 and here hydrogen, here hydrogen. This is styrene or phenylethene. Styrene or phenylethene. Okay, the question asking you, draw the structure of polymer. Draw its polymer form. This is monomer. Draw its polymer structure. So what you have to do here, just remove double bond, make it single bond. Then this type of unit will join both sides. Then put n. It means this is one unit. This type of unit will join both sides. Okay, now this is polystyrene and this is polypropene. Similarly, you can make this is vinyl chloride. Similarly, remove double bond and put bracket, put n over here. So this is polyvinyl chloride. Okay, so you can make like this. You can make all monomer to polymer this way. Okay, next one we have to discuss here how to identify monomer. We discuss how to convert the structure of monomer to polymer. We discussed. Next one, you have polymer. You have the structure of polymer. Okay, then you have to convert its monomer. Okay, you have the structure of polymer. From polymer, you have to find its monomer. See here one example. Here this is one polymer. Okay, this is one polymer. You have to find its monomer. So there are different steps to find its monomer. First, you have to identify the repeating unit. You have to find repeating unit. So which one is repeating unit here? CH3. Look here. When you observe this carefully, you can see this type of unit repeating many times. So this is repeating unit. So if you have one polymer, you have to find its repeating unit. You have to find its repeating unit. So this is the repeating unit. So you want to draw the structure of monomer. So you find first repeating unit. So draw here the structure of repeating unit. CH3, hydrogen, hydrogen. This is repeating unit. Clear? After that, you have to put the double bond between this. Put double bond. So identify repeating unit, then you have to put double bond. Now this is the structure of monomer. Clear? So if you have a polymer structure, you can find its monomer simply. You have to find repeating unit, then you have to put a double bond between carbon. Clear? Then it will be monomer. Sometimes you have the structure of polymer like this. You have the structure of polymer like this. Okay, you know this is polytetrafluoroethene. Polytetrafluoroethene also called Teflon. Teflon. Okay, the another name of polytetrafluoroethene, Teflon. Okay, so this is the structure of polymer. You want to draw its monomer. So simply you can find this is the repeating unit. Okay, carbon, carbon, then 4 fluorine. So this is repeating unit. So what you have to do here, just remove the bracket, okay, then put double bond here. So you know this is repeating unit, then put double bond. So now this is the structure of monomer. It is tetrafluoroethane. So to find monomer, it is very simple. So you have to find repeating unit first, then put double bond between them. Okay, between two carbon atom you have to put double bond, then it will be monomer. Okay, next one we have to discuss here condensation polymers. Condensation polymers. Condensation polymers mean here polymers are formed from different type of monomers. In addition polymer, there is only one type of monomer, ethene, polythene, styrene, polystyrene. There is only one type of monomer. Okay, but in condensation polymers there are different type of monomer, different type of monomers, and these monomers have different functional group, and this functional group react together form a long chain polymers. Such type of polymers are called condensation polymers. Okay, so addition polymers mean repeated addition of monomers to polymer. Only one type of monomers, ethene, polythene, propene, polypropene, styrene, polystyrene. These are addition polymers. But condensation polymers mean there will be different type of monomers, and these different monomers have different functional group. Alcohol, carboxylic acid. Okay, this type of different monomers react together form a long chain polymer. Okay, also during formation of condensation polymer there will be some side product. So here condensation polymers mean there will be different type of monomer and they have different functional group, and polymers are formed with side product. I will give you more example for this. Okay, so here example for condensation polymers: nylon, Dacron or terylene. Terylene, another name of terylene, Dacron. These are example for condensation polymers. Okay, and here next one we have to understand here difference between addition polymers and condensation polymers. We already discussed their difference. So see here addition polymers and condensation polymers. Addition polymers mean only one type of monomer. Condensation polymers mean there will be different type of monomer. Okay, and here addition polymers are formed without any side product. Addition polymer, just monomer changed to polymer, there is no side product. But during condensation polymer, there is some side product will be formed. Polymers are formed with some side product. Side product mean during formation of condensation polymer there will be hydrogen chloride or water vapor. This type of molecules will be side product. So here side product will be eliminated. Okay, and here during addition polymers, monomers which contain carbon-carbon double bond, okay, and repeated addition of this monomer, carbon-carbon double bond or unsaturated compound will change to saturated compound. Carbon-carbon double bond will change to carbon-carbon single bond. But in condensation polymer, monomers which contain different type of functional group, this functional group react together change to polymer by eliminating some side product. Okay, so these are the major difference. Here addition polymer only one type of monomer, condensation polymer different type of monomer. Addition polymers are formed without side product. Condensation polymers are formed with side product. Addition polymer monomers which contain carbon-carbon double bond. During polymerization, it will change to carbon-carbon single bond. During in condensation polymer, monomers with different functional group react together, form a long chain polymer. Okay, so these are the major difference between addition and condensation polymer. Example for addition polymer, polythene. Okay, example for condensation polymer, nylon or Dacron. Clear? Okay, next one we have to discuss here example for condensation polymer. Example for condensation polymer, first one, nylon. Monomers of nylon is diamine and carbonyl chloride. Diamine and dicarbonyl chloride. These are the monomers. Amine means compounds which contain functional group NH2. The compound hydrocarbon with NH2. Such type of compounds are called amine. Okay, and another one, carbonyl chloride. Carbonyl chloride means compound which contain carbon double bond oxygen Cl. Hydrocarbon with a carbon double bond oxygen single bond Cl. Such type of compounds are called carbonyl chloride. So monomers of nylon is diamine and dicarbonyl chloride. Diamine means compound which contain two NH2 group. See here, these are the monomers. Okay, so here in this compound, look here, 6 CH2 repeating 6 times. CH2, look here, 1 2 3 4 5 6 CH2 repeating 6 times. Then each end you can see NH2. Each end you can see NH2. Okay, so here it is diamine. Diamine means NH2 coming 2 times. That's why this type of compounds diamine. So name of this compound 1,6-diaminohexane. This is hexane because here 6 carbon and single bond hexane. But this is first and 6 carbon, there is NH2. That's why this compound is called 1,6-diaminohexane. Okay, so this compound shortly we can write it like this. Here this box represent CH2. This box represents CH2 6 times. Okay. So sometime you can see in past paper or book like this. Okay, so here this box represent hydrocarbon. Clear? So here in this molecule, this box represent NH2, CH2 6 times NH2. Name of this compound 1,6-diaminohexane. 1,6-diaminohexane. This is one of the monomer of nylon. Another monomer, look here, there is two monomer for nylon. One is 1,6-diaminohexane. Second monomer, this is the second monomer. This monomer which contain carbon double bond oxygen single bond chlorine. Carbon double bond oxygen single bond chlorine. Okay, this type of compound I told you, carbonyl chloride. So how many CH2 here? 1 2 3 4. Okay, also name of the compound, we know name of the compound which depends on the number of carbon atom. We have to count. Look here this is also carbon double bond oxygen. So we must include all carbon atoms. So how many carbon atom here? 6 carbon atom. So here name of this compound hexane. Here also 6 carbon. So hexane 1,6-dioyl chloride. Carbonyl chloride. Actually this is carbonyl chloride. Okay. That's why it is dioyl chloride. carbonyl. This YL coming from here, carbonyl chloride, YL. Okay, and here this is coming 2 times, that's why here di. So hexane 1,6-dioyl chloride, or simply you can say here what are the monomers of nylon. Simply you can say diamine and dioyl chloride, dicarbonyl chloride or diamine. These are the monomers. Simply you can say. Okay. Now see here, this molecule we can represent. This molecule we can represent like this. Okay. Here CH2 1, 2, 3, 4. CH2 4 times. Then each end carbon double bond oxygen single bond chlorine. So I used like this here one box, then carbon double bond oxygen chlorine, carbon double bond oxygen chlorine. So this box represents CH2, it repeating 4 times. I told you previous case, this box CH2 6 times, then each end NH2. Now here this box CH2 4 times, then each end carbon double bond oxygen chlorine. So why I used here different box, here one shaded box, here without shading. Why different box? This different box indicate this box one hydrocarbon, this box different hydrocarbon. Because look here, CH2 6 times here CH2 4 times. So these hydrocarbons are not same, they are different. That's why we use here different colored box or different shaded box. Clear? Okay, so these are the things you have to remember about monomers of nylon. So which are monomers of nylon? Diamine, dioyl chloride. Diamine, dioyl chloride. This is diamine, this is dioyl chloride. Clear? Now look here, these two monomers which contain different type of functional group. Here amine functional group, here carbonyl chloride. So different functional group reacting together and eliminate some side product. Look here. This is one monomer and this is another monomer. So during this chemical reaction, this hydrogen and chlorine reacting together and hydrogen chloride will be eliminated minus HCl. When these two monomers reacting together, hydrogen chloride, okay, from this molecule one of this hydrogen and from this molecule one of this chlorine will be reacting together and remove like hydrogen chloride. Rest of the part we can join like this. Look here, same thing I did here, box here NH2, then here one hydrogen removed, still there is one hydrogen, nitrogen single bond hydrogen. Okay, this chlorine removed, so what is left here? Carbon double bond oxygen, this carbon double bond oxygen. Okay, here same carbon double bond oxygen single bond chlorine. Okay, so this is the macromolecule. Okay, and here I used here 2 molecule only, so here 2 unit. During polymerization, you know, millions or thousands number of molecules reacting together, so there will be unlimited long chain will be there. Okay, so simply you can do it like this. See here one box, okay, here one box, then here NH. Okay, this is one, this is diamine, here box NH, here box, same this box carbon double bond oxygen. Okay, and here imagine if there is one more molecule, again this chlorine will be removed and another molecule will join over here. Okay, so this type of addition will be repeating and unlimited. Look here, this structure will continue over here, also this structure will continue over here. Or during this chemical reaction, one of this hydrogen and this chlorine will be removed and the next unit will join here, and another unit will join here. After that, one unlimited structure will be formed. Clear? So this type of structure, this type of molecules are called nylon. This is nylon. Clear? So here we discuss what are the monomers of nylon. Monomers of nylon is diamine and dioyl chloride. Diamine means CH2 6 times, then each end there will be NH2. Dioyl chloride means CH2 4 times, then each end there will be carbon double bond oxygen and single bond chlorine. Okay, the compound with the NH2, that is amine, compound with the carbon double bond oxygen Cl, that is carbonyl chloride. Okay, and here we use different box, then we will write these things NH2. This part one box. Here we will draw this one, carbon double bond oxygen chlorine, carbon double bond oxygen chlorine. This part we will include in a box. These boxes are different because here CH2 6 times, here CH2 4 times. They are different hydrocarbon. That's why we use different box. When they reacting together, one hydrogen and chlorine remove, such like hydrogen chloride. I told you before, in condensation polymer there will be some side product like hydrogen chloride or water vapor or any some molecule or any molecules. Okay, so here hydrogen and chlorine removed and the rest of the part joined together. Okay, and here this bond here, nitrogen and carbon joining here. This is one molecule and this is another molecule, and this bond helps to join these two different units. Okay, also here you have to remember a new term, amide linkage. Amide linkage. Amide linkage. In case of ester, you learned in ester linkage. Now you have to learn amide linkage. Amide linkage means bond between NH and carbon double bond oxygen. Here this is one molecule, here NH. This is another molecule, there is carbon double bond oxygen, and bond between NH and carbon double bond oxygen. This bond is called amide linkage. Amide linkage. And polymer which contain amide linkage, such type of polymers are called polyamide. This type of polymers are called polyamide. Okay, so what is amide linkage? Amide linkage means bond between amine and bond between NH and carbon double bond oxygen. This bond is amide linkage. Polymer which contain amide linkage, such type of polymers are called polyamide. Polyamide. Okay, polyamide means polymer which contain many amide linkage. That's why we will say polyamide. Okay, similarly, polymer which contain ester linkage, we will say polyester. Okay, so here we have to understand polyamide. So this is amide linkage. Also here amide linkage. These are amide linkage. Okay, so here this is the formation of nylon. Clear? Okay, next one we have to understand here terylene or dacron. Terylene or dacron. Next example for condensation polymer, terylene or dacron. Monomers of terylene or dacron. Monomers, dialcohol and dicarboxylic acid. Dialcohol and dicarboxylic acid. Okay, that is monomers. Monomers of dacron or terylene. Monomers which contain carboxylic acid and alcohol. Okay, this carboxylic acid and alcohol react together form ester linkage. So we learned before we learned before, alcohol and carboxylic acid react together form ester in presence of concentrated sulfuric acid. Concentrated sulfuric acid helps to remove water molecule. Similarly here, pterylene or dacron which contain monomers with carboxylic acid and alcohol. Carboxylic acid and alcohol react together form ester by eliminating water molecule. Carboxylic acid and alcohol react together form ester by eliminating water molecule. So here ester, pterylene or dacron which contain ester functional group, ester linkage. Before we learned nylon which contain amide linkage. So such type of polymers are called polyamide. Now nylon or pterylene or dacron which contain ester linkage. So such type of polymers are called polyester. Okay, polymer which contain ester linkage, it is polyester. See here example. See here we are talking about pterylene or dacron. So pterylene or dacron which the monomers which contain two different functional group, carboxylic acid and alcohol. You remember this is the carboxylic acid functional group and this is alcohol functional group. Okay, so these are the structures of monomers of pterylene or dacron. These are the structure. Okay, so here see this structure, there is carboxylic acid, C double bond OOH. Here also carbon double bond oxygen single bond OH. So this compound which contain carbon double bond oxygen single bond OH. Okay, COOH. So there is two COOH. That's why we will say it is dicarboxylic acid. Dicarboxylic acid. And this is one ring structure. This type of ring. Name of this ring benzene. Okay, look here you can give number. This is first carbon, 2 3 4. So in first carbon and fourth carbon there is C double bond OOH. So name of this compound is benzene 1,4 dicarboxylic acid. Benzene 1,4 dicarboxylic acid. This structure is benzene. First carbon and fourth carbon there is carboxylic acid, 2 carboxylic acid, that's why dicarboxylic acid. Okay, first and fourth position, 1,4 dicarboxylic acid, benzene 1,4 dicarboxylic acid. And this is first monomer and this is second monomer. There is two monomers for pterylene or dacron. Okay, this is first monomer and this is second monomer. And here look here, this molecule which contain OH. Okay, so here 2 carbon, so you can say ethane, first and second carbon, ethane 1,2 diol. Here OH, you know, alcohol, or okay, so alcohol, name of alcohol end with OL, name of carboxylic acid end with oic acid. Okay, so here two OH, that's why we will say here diol. Okay, and first carbon, second carbon, that's why 1,2 diol, and here 2 carbon, that's why ethane 1,2 diol. Simply you can say what are the monomers of pterylene or dacron? Dicarboxylic acid and dialcohol. Simply you can say here what are the monomers of pterylene or dacron? Dicarboxylic acid, dialcohol or diol. These are the monomers. Okay, and see here this monomer we can draw like this. In previous case we use CH2 6 times, we used a box. Similarly here this part we can include in a box, then C double bond OH. Okay, each side there is carbon double bond oxygen single bond OH. Rest of the part we included in a box. Clear? Similarly this one, here OH, CH2, these two carbon we can include in a box, then OH, each side OH. Clear? So here looking this one, you can say the monomer is dicarboxylic acid and dialcohol. So these are the monomers of terylene or dacron. Okay, next one we have to understand here how they react, how these monomers react. We know already formation of ester. During formation of ester, from carboxylic acid, OH will be removed. During formation of ester, carboxylic acid, OH will be removed, and from alcohol, hydrogen will be removed. Okay, this OH and hydrogen combine to form water molecule, and water molecule will be side product. During formation of nylon, HCl is side product. During formation of terylene or dacron, water is side product. Clear? So look here, after removing this OH and hydrogen, what is left here? This box here, and here same thing I did here, carbon double bond oxygen OH. Okay, and here this is carbon double bond oxygen, and here in this part hydrogen removed. So still here oxygen bonded to this box, and here OH. Clear? And see here, these two different molecules joined over here, So this type of bond is called ester linkage. This is ester linkage. In previous case, in case of nylon, we learned amide linkage. In case of nylon, we learned amide linkage, and here we have to understand here ester linkage. Okay, so this type of polymer which contain ester linkage, we will say polyester, because this type of ester which contain many ester linkage, that's why we will say polyester. Poly mean many, polyester. Okay, and see here, this is polyester, or this is the terylene. Okay, terylene or dacron, this is polyester because it contains ester linkage, and this is terylene or dacron. So here we did only 2 units. Here this one monomer, this is another monomer, they react together form, this is the macromolecule. Okay, and here 2 units. But actual polymer which contain many unlimited molecules, so this is the structure for terylene or dacron. This is only simply 2 units, but actual polymer it contains many units. This unit will continue over here, and another unit will continue over here. So this is unlimited structure. So look here, here another, in this end another unit joining. So here this OH will be removed. Okay, imagine another unit coming over here. So from this part hydrogen will be removed. So look here, same thing I did here, one box here, carbon double bond oxygen. Okay, then this box over here, oxygen. Okay, so same thing will repeat. So this is carboxylic acid, and this is alcohol. Again this is carboxylic acid, this is alcohol. From carboxylic acid OH will be removed. From alcohol hydrogen will be removed, and rest of the part will add. Okay, repeated molecule will be add together. Okay, and here many water molecule will be removed. Clear? So this is the formation of terylene or dacron. So here we discussed monomers of terylene or dacron. Monomers of terylene or dacron mean this is the one monomer. Okay, it is benzene 1,4-dicarboxylic acid. Okay, here 2 COOH, here first and fourth carbon there is carboxylic acid, and this ring structure called benzene. So name of this compound is benzene 1,4-dicarboxylic acid. And here this is ethane 1,2-diol. Here 2 carbon, and first and second position there is oil. Okay, OH functional group. That's why ethane 1,2-diol. ethane 1,2-diol, and we can represent this molecules like this. Here box COOH and here box OH. Okay, here carboxylic acid and alcohol functional group react together and water molecule will be removed, and this is the ester linkage. Polymer which contain ester linkage called polyester. Okay, and here many units join to form this type of structure. Okay, so remember, many units join together mean this OH and OH will be removed, and from here hydrogen and hydrogen will be removed. Rest of the part will add together and it will be pterylene or dacron. Clear? Next one, we have to understand here uses of pterylene, different uses of pterylene. So this is pterylene. Here pterylene used to make cloths, polyester thread. Okay, there are many uses here. These are the some uses of pterylene. It used to make cloths, also polyester thread. Okay, and in previous case we discussed nylon. Okay, nylon, different uses of nylon. Nylon used to make fishing net, nylon thread, also it used to make car seat belt, also used to make carpets. Okay, so here different uses of nylon, used to make thread, fishing net, car seat belt and carpets. Okay, next one, we have to discuss here some properties of polymers. Actually, synthetic polymers are plastic. And most of the plastics are made from naphtha. Naphtha is the one of the products obtained from crude oil. Okay, so here synthetic polymers are plastic, and these plastics are made from naphtha, and this is from crude oil. Here some properties of plastic or some properties of polymers. Polymers are insulated. Polymers do not conduct electricity, and polymers do not react with water, air or acid. Okay, polymers are highly unreactive, so we can keep food and other materials in plastic bag or plastic bottle. Okay, and here plastics are or polymers are lighter and easy to carry. Okay, these are not heavy, it is lighter, low denser and lighter, so we can carry easily. And polymers are strong and do not break easily. Similarly here, it do not catch fire easily. So these are the some properties of polymers. Okay, do not conduct electricity and do not react with acid, air, water, so we can keep food inside this plastic bottles, and this plastic or polymers are lighter and easy to carry. Okay, it is strong and do not break easily. Similarly here plastic do not catch fire. Okay, next one, we have to understand something related to high density polyethylene, high density polyethylene, HDPE, high density polyethylene. High density polyethylene mean here this polymer polyethylene, they have long chain structure, and these long chains are packed tightly together. They are packed tightly. Okay, that's why this polymers, they have high density, they are hard and strong. That is high density polyethylene. So high density polyethylene mean the polymer chains are closely packed, tightly packed, and they are hard and strong. Similarly here you have low density polyethylene. So low density polyethylene mean they have branched structure. Okay, linear chain with branch. So because of this branch, okay, so here high density polyethylene mean polyethylene, they have long chain, they are packed tightly. But low density polyethylene mean they have this type of branched structure and they cannot pack tightly, and they have low density. And this low density polyethylene, they are not much hard and strong. They use it to make plastic bag, cling film, to make food. Okay, cling film for food package and plastic bags. These are the different uses of low density polythene. Clear? One, we have to discuss here pollution problems. Pollution problems of polymers. So we discussed, we know there are wide variety uses for polymers in our daily life. Okay, we using polymers or plastic in different purpose. Okay, but these polymers make pollution. These polymers making different type of pollutions. Okay, so see here, one of the major problem, polymers are non-biodegradable. Polymers are non-biodegradable. Polymers, after usage we throw the polymers or plastic, okay, and this plastic or polymers, it will stay in the soil, it will stay in the ground long years. Okay, it do not break down by actions of bacteria or other microorganism, means they are non-biodegradable. Okay, so they making soil pollution. Okay, and it will affect the growth of plants, aquatic animals, aquatic plants, etc. They make pollution. Okay, another one, after burning this plastic, so landfilling it makes soil pollution. Landfilling mean after usage we keep or we put the plastic underground, so this is landfilling. It make pollution because plastics are non-biodegradable. Okay, and another way to dispose polymers or plastic, burn them. After burning plastic, they make harmful gases such as CFC, chlorofluorocarbon. This type of harmful gases formed. Okay, these harmful gases make air pollution. They make air pollution. So this type of disposing also making pollution. Okay, so here we discuss the pollution problem. The major source, they are not biodegradable. Okay, they make soil pollution. After burning they form harmful gases and they make air pollution. Clear? So how to reduce this pollution because of polymers? How to reduce polymer pollution? To reduce this pollution, some suggestions, we can reduce the usage of plastic. Okay, single usage plastic or polymers, reduce their usage. Or another one, recycle this type of plastic or polymers, recycle and try to make useful materials, make useful material with the help of this type of plastic. So reduce the usage of plastic or recycle the plastic. And another one, this is very important, use biopolymers. Biopolymers mean polymers which degrade by actions of bacteria. I told you before, normal polymers or plastic, they are non-biodegradable. They will stay in the ground, they will stay in the soil long years, many years. So they are non-biodegradable. Instead of such type of polymers, we have to use biodegradable polymers. Biodegradable polymers mean polymers, it will degrade by actions of bacteria. Okay. Example for biodegradable polymers, polylactic acid. Polylactic acid is one example for biodegradable polymer. It contains ester linkage and it will degrade by actions of bacteria. Polylactic acid. Okay. Or we can use photodegradable polymer, biodegradable polymer, biopolymer, or photodegradable polymer. Photodegradable polymer mean polymers, it will degrade, it will break down in presence of sunlight. Okay, it will break down in presence of sunlight. So we can use here, we can reduce we can reduce pollution problems using this method. Reduce the usage of plastic or polymers, especially single usage plastic or polymers. Okay, and recycle these polymers or plastic and make them useful product. Okay, use biopolymer instead of normal plastic or polymers. Okay, photodegradable polymers also helps to reduce pollution. Photodegradable polymers, it will degrade by actions of sunlight. Okay. Okay, next one we have to discuss here natural polymer. We already discussed synthetic polymer. We already discussed synthetic polymers. Synthetic polymers are man-made polymer. Okay, so next one we have to discuss here natural polymers. Natural polymers mean polymers. Naturally getting polymers are called natural polymer. Polymer which obtain from plants or animals. Okay, such type of polymers are natural polymer. Polymers such as carbohydrate, cellulose, protein, oil or fat, this we can find in plants. Okay, here first we have to discuss here carbohydrate. So here example for natural polymer: protein, carbohydrate, cellulose, oil or fat. This type of substances are example for natural polymer. Okay, so actually oil or fat not polymer. We will discuss about this later. So here you understand protein, cellulose, carbohydrate. These are example for natural polymer. Carbohydrate, the monomer, the basic building unit of carbohydrate is glucose. The simplest unit of carbohydrate, it is glucose. Okay, so see here, you can see here structure of glucose. So here this structure which contain two alcohol group. Okay, so we can represent the structure of glucose like this. Okay, here this box represent hydrocarbon and each side there is OH. Okay, and here the simplest unit, look here, the simplest unit of carbohydrate, glucose also called monosaccharide. Simplest unit of carbohydrate, glucose also called monosaccharide. Mono mean one. Okay, so here two glucose join to form disaccharide. Monosaccharide mean one glucose. Disaccharide mean two glucose join to form disaccharide. Polysaccharide mean many glucose join to form a big heavyweight molecule. Such type of polymers, such type of molecules are called polysaccharide. So polysaccharide, it is polymer. So you understand here carbohydrate, the monomer of carbohydrate, glucose also called monosaccharide. Okay, two glucose molecules join to form disaccharide. Many glucose molecules join to form polysaccharide, and this is the representation of structure of glucose. Okay, this is hydrocarbon, each side there is OH. Okay, next one we have to discuss here how two glucose molecules react together. How two glucose molecules reacting together. So look here, this is one glucose molecule and this is another glucose molecule. Okay, so here when two glucose molecule reacting together, here this OH and one of this hydrogen, okay, one OH and one hydrogen combine to form water molecule and eliminate water molecule, and rest of the part will be joined. Okay, here this part joining with this oxygen and here this molecule formed. Now see here, two glucose molecules join to form a molecule. I told you molecule which contain two glucose, that is disaccharide. Monosaccharide mean molecule which contain only one glucose. Here two glucose molecules join to form disaccharide. Okay, So this way many glucose molecules join together by eliminating water molecule and form polysaccharide, and this polysaccharide is carbohydrate. This is the structure of carbohydrate. Draw the structure of carbohydrate. You can draw, this is the structure of carbohydrate. Okay, so what is the monomer of carbohydrate? Glucose. Draw the structure of glucose. You can draw this structure. Okay, no need to draw the complete structure. You can show like this box and each side OH. This represent glucose molecule. Okay, two glucose molecules combine to form disaccharide by eliminating water molecule. Okay, many glucose molecules after elimination of water they form polysaccharide, and here it represents polysaccharide. Okay, so here this is example for condensation polymer. We know condensation polymer mean here different type of monomer. Okay, and here side product formed, water eliminated, so water is side product. So this is example for condensation polymer. Okay, so carbohydrate is example for condensation polymer. Also cellulose also found in plants, it is example for condensation polymer. It is natural polymer. Okay, and the basic building unit or monomer of cellulose also glucose. Monomer of carbohydrate glucose, monomer of cellulose glucose. Okay, so these are the things we have to understand here. Carbohydrate, monomer of carbohydrate, structure of carbohydrate. Okay, and here disaccharide, polysaccharide. These are the things we have to. Okay, next one we have to discuss here protein. Okay, protein also another example for natural polymer. Protein. The monomer of protein is amino acid. Monomer of protein is amino acid. See here, this is the structure of amino acid. This is the structure of amino acid. NH2, CHR, C double bond OOH. So amino acid which contain two functional group. One molecule of amino acid which contain two functional group. Okay, NH2 and COOH. Okay, NH2 means this functional group called amine. COOH we know carboxylic acid. So amino acid which contain two functional group amine and carboxylic acid, NH2 and COOH. So protein is natural polymer. Monomer of protein is amino acid which contain two functional group amine and carboxylic acid. Okay, and see here, this is the structure of amino acid, NH2, CHR, COOH. Look here, NH2, here nitrogen and two hydrogen, NH2. Here CHR, C double bond OOH. This R, you know there are 20 different type of amino acid. There are 20 different type of amino acid. Okay, each amino acid different here, this position. Okay, each amino acid, this R group will be different for different amino acid. Instead of R may be hydrogen, CH3 or C3H7. Okay, this type of group. Okay, so there are 20 different type of amino acid. Each amino acid different here. Okay, so this is you have to understand about amino acid. Next one we have to understand how amino acid react, how different amino acid react together. Okay, so look here, this is one amino acid and this is another amino acid. We learned nylon. Nylon different monomer, they have dicarboxylic acid and diamine. Okay, nylon, the monomer of nylon which contain, there are two monomer for nylon, diamine, dicarboxylic acid. So we learned how diamine or how amine and carboxylic acid will react. Same way, same method also we have to apply here in protein also. Okay, so here in NH2, one of this hydrogen will be removed. From carboxylic acid, this OH will be removed. Okay, and water molecule will be eliminated. Okay, and here carbon double bond oxygen, single bond NH. Look here, carbon double bond oxygen, single bond hydrogen. From this position OH removed, and from here hydrogen removed, and they eliminated in the form of water molecule. Okay, so here 2 unit. Okay, you know, actual polymer, actual protein, it contains 1000 or many amino acid molecules. Okay, so here this part and this part, different amino acid will join repeatedly and it form unlimited long chain structure. Okay, now see here, this is the structure, this is the bond. This bond will join two different monomer, two different amino acid will join over here. Also we learned this type of bond in nylon. In nylon we learned special name for this bond. It is amide linkage. Amide linkage. And polymer which contain amide linkage we will say polyamide. So nylon and protein are example for polyamide. Nylon, it is synthetic polyamide. Protein, it is natural polyamide. Clear? Also one different, nylon, it is synthetic polymer, it is non-biodegradable polymer. But protein, it is biodegradable, it is biological material, biodegradable, and it is natural polymer. Okay, this is the difference between nylon and protein. What is the similarity between nylon and protein? Both polymer which contain amide linkage. Okay, so here this is one amino acid and this is another amino acid. So you remember always carboxylic acid, from carboxylic acid OH will be removed. From NH2 one of the hydrogen will be removed. So rest of the part you have to join. Clear? Now see here, I told you this is the structure of protein. This is the structure of protein. This is the structure. Okay, I told you here there are 20 different type of amino acid. Each amino acid R will be different. Okay, so this is the protein. Sometime you can see in textbook or sometime you can see in past paper this type of structure. This type of structure represent protein. This type of structure represent protein. Look here, NH. Here instead of this CHR, I used one box. It represent one alkyl group. It represent this group. Okay. After that, carbon double bond oxygen, nitrogen single bond hydrogen. Then again another box. Here this is CHR. This are not same because here this R and this are different. For different amino acid R will be different. That's why I used here different type of box. Clear? So here this is amide linkage and this type of polymers are called polyamide. Next one we have to discuss here importance of polymers. Importance of polymer. Here enzymes, we know enzymes are made of protein. Enzymes are biological molecules made of protein and they catalyze many chemical reactions which takes place inside living cell. So here enzymes are made of protein and it is very important for living organism. Similarly here collagen is another polymer. Okay, and here skin, bone, teeth, these are made of collagen and this is also another important polymer. Okay, and here hemoglobin also made of protein. Hemoglobin, it helps to carry oxygen to different parts of our body. Also it carry carbon dioxide, harmful carbon dioxide gas from different tissue and it helps to carry to outside our body. Okay, so all these things made of protein, enzyme, collagen, hemoglobin. These are very important biological material inside living body, and these are made of protein. Okay, next one we have to discuss here oil or fat. Oil or fat, it is example for natural polymer. Oil or fat, it is natural polymer. It is condensation polymer. It is condensation polymer. During formation of oil or fat, water molecule formed as side product, and it is example for condensation polymer. The monomers of oil or fat. Oil or fat. Look here, this is oil or fat. Actually, oil means liquid form of fat. Oil means liquid form of fat, that is oil. So here monomers of oil or fat, fatty acid and glycerol. Fatty acid and glycerol. These are the monomers of oil or fat. Okay, glycerol and fatty acid. And these are the structure of glycerol. This is the structure of glycerol, and this is the structure of fatty acid. Glycerol means CH2OH, CHOH, CH2OH, CH2OH, CHOH, CH2OH, and this compound which contain 3 alcohol functional group. That's why glycerol also called a trihydric alcohol or triol. Okay, glycerol which contain 3 OH group, that's why we can say glycerol trihydric alcohol or triol. You understand? And here this is fatty acid RCOOH. Here this R represent hydrocarbon with carbon number around 17. Okay, so this is fatty acid. Fatty acid and glycerol react together form oil or fat. So this is natural polymer oil or fat. This is the structure of one molecule of oil or fat. Okay, this is the macromolecule. This is macromolecule oil or fat. This is one molecule. Okay. And here, look here, let us see here how glycerol and fatty acid react together. So look here, fatty acid which contain carboxylic acid and glycerol which contain alcohol. So from carboxylic acid we know OH will be removed. I told you before, from carboxylic acid always OH functional group will be removed. From alcohol, hydrogen will be removed. Okay, so here 3 OH group, all 3 hydrogen will be removed. Also listen here, this is 3 fatty acid, glycerol which contain 1, 2, 3 OH functional group, 3 reactions. There are 3 reaction sites. So we need 3 fatty acid molecule. Glycerol which contain 3 OH functional group, 3 reaction site. So we need 3 fatty acid molecule. One fatty acid react over here, another here. Okay, so here 3 OH molecules will be removed. From here 3 hydrogen will be removed. So totally here 3 water molecule will be removed. So during formation of one molecule of oil or fat, there will be 3 water molecule will be eliminated. Clear? So here OC double bond O. What type of linkage this? You remember what type of linkage this? This is ester linkage. We learned this type of linkage in polyester. We learned this type of linkage in polyester or Dacron. Polyester, it's another name, Dacron. So polyester which contain this type of linkage. Okay, this is ester linkage. Clear? So here this is alcohol, this is carboxylic acid. They are reacting together form ester. Oil or fat, this is one kind of ester. It is natural polymer. Clear? So you just check their structure, and here three functional group, that's why we choose here three fatty acid molecule, and here hydrogen and OH will be removed. So just we do like this, look here, CH2, 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 CH, CH2, here same thing I did, then here three oxygen, hydrogen removed from alcohol, hydrogen removed. Okay, then we have to look over here, carboxylic acid, this OH removed. So what is left? RC double bond O. So I choose here this oxygen making bond with the carbon, then double bond oxygen R. Okay, this is carboxylic acid, RC double bond O. So here also, look here three molecules. So one molecule over here, again it will repeat, one here. Okay, so this is same thing, oil or fat. Clear? Next one we have to discuss here, I told you before, this is condensation polymer, also it is natural polymer. Oil or fat, it is condensation polymer because water molecule eliminated, and it is natural polymer. Next one we have to discuss here, importance of fats in our body. What is the importance of oil or fat in our body? Oil or fat, it will break down in our body. After breaking down, it produce glycerol. This glycerol provide energy for our work. Okay, so oil or fat, it will break down in our body and it produce energy for our body. Okay, so here there are two different type of oil or fat, saturated fat and unsaturated fat. We know saturated and unsaturated. Unsaturated mean hydrocarbon. Here I told you here this R mean hydrocarbon. Okay, so saturated mean here this hydrocarbon, there is carbon single bond only. Unsaturated mean in this hydrocarbon there is carbon double bond. So there are two different type of oil or fat, saturated fat and unsaturated fat. So here saturated fat, unsaturated fat is better for our body. First point I told you, oil or fat, it will break down in our body, form glycerol, and this glycerol provide energy. There are two different type of fat, saturated fat and unsaturated fat. Here unsaturated fat is better for our body. Which one? Unsaturated fat, fat which contain carbon double bond. Unsaturated one better. Okay, saturated fat, it cause heart disease. Okay, saturated fat, it cause heart disease. So unsaturated fat is better than saturated fat. Clear? Okay, next one we have to discuss here, saponification. Saponification means process by which soap making. The soap making process called saponification. The process by which soap, okay, soap using for cleaning. Okay, this soap production called saponification. Here oil or fat reacted with sodium hydroxide, it produces soap and glycerol. So glycerol is a side product during soap production. So look here, we learned already, this is the structure of oil or fat. This oil or fat reacted with sodium hydroxide, it formed glycerol. It produced glycerol, and this is the molecular formula for soap. This is the structure of soap. Okay. So look here, I told you before, oil or fat, there is three reaction site. 1, 2, 3. That's why we using here 3 sodium hydroxide. One molecule of oil or fat, it will react with 3 sodium hydroxide molecule. Okay. Then from this part, from here, CH2O, CH2O, and from here this part will break. Okay, then this hydrogen will join over CH2OH, CHOH, CH2OH. Okay, that is glycerol. And from here, R C double bond oxygen, R C double bond oxygen ONA, that's here, R C double bond O ONA. So this is 1 2 3, okay, 3 molecules of R C double bond O ONA, and this is soap, okay, soap using for cleaning, we know, okay. And this is the process of saponification. Glycerol, oil or fat reacted with sodium hydroxide, soap formed, and glycerol is a side product during this process. Clear? Okay, next one we have to understand here, breaking down to monomer. Breaking down to monomer. Okay, so we learned here macromolecule polymers are formed by repeated addition of monomer. Okay, so here polymer, okay, depolymerization, we can say this process, polymerization means process by which polymers are formed. Depolymerization means polymers breaking down to small monomers. This process is called depolymerization. Okay, we have to understand here some depolymerization process. See here, starch. Starch after hydrolysis, it will change to glucose. We know starch produced by glucose. Many glucose unit join to form starch. Starch after hydrolysis, it will go back to glucose. Okay. Similarly here, protein. We know proteins are made by amino acid. Many different amino acid join to form protein. Protein after hydrolysis, it will go back to amino acid. Okay, protein after hydrolysis, it will change to amino acid. Similarly here, oil or fat. Oil or fat after hydrolysis, it will change to its monomer, glycerol and fatty acid. Okay, so remember this, starch to glucose, protein to amino acid, oil or fat change to fatty acid and glycerol. Clear? So these are the things we have to discuss in organic chemistry. Okay, so you can check its past paper, you can check playlist and you can see past paper related to this topic. Okay, and thank you for watching this channel.